Alright, so I did number 19. And number 19 reads, a rabbit runs up 14 steps, going up either 1 or 3 levels with each stride. How many ways can it go up? Okay, seems simple enough, but it's really not. So, first I set two variables. X is number of times it goes up with 1 stride, and Y is the number of times it goes up with 3 strides. Okay, so obviously from that we can tell X and Y have to be integers. So the first thing I know is make an equation. So X plus 3Y, right, because going from here, equals 14. The total number of steps that he takes. And it goes up. So first thing I notice is Y, the max it can be is 4, right? Because 3 times 4 is 12. Now 3 times 5 is 15, so that's over 14. So the first thing I did was made intervals. Because we know that the 14 steps can be any combination of X and Y, of these two possibilities. So since I know that Y has to be anywhere from 0 to 4, I just plugged in all these values. So first plugged in 0 for Y, and got 14 for X, then plugged in 1, 11, 2, 8, 3, 5, etc. And so I got my X interval is from 2 to 14. But anyway, so first thing I did when looking at this was, okay, so here's the different possibilities, but just because you can go up, you can have 2 1 strides, and you can have 4 3 strides. There's different ways you can do that. You can go like 1 stride length 1, and then do a stride of length 3, and then do a stride of length 1, and then a stride with length 3. You know what I mean? You can like do different combinations of these right here. So in order to find that, the first thing I did was I looked at it like physically. So here, so for example, with the point 11 1, okay, so we have 11 1 strides and 1 3 stride, right? So you can obviously just put different combinations would just be here. So the number of ways of counting is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 different ways that can happen. All right, that's easy enough. Also, only one way you can have 14 1 strides and 0 3 strides. Now, the problem you run into is when you have things like 2 3 strides or 3 strides, because you have a picture like this, but you can't just say, because now when you try and do different pictures in your mind, you think, well, if you move these circles in here, there's way too many combinations to count, so you can't count them. So we need to like use something from a different class that I've taken. It's called N choose R. Basically, it's a number of ways R items can be selected from a set of N items. So it applies right here. So N choose R is equal to N factorial over N minus R factorial, R factorial. So using that, so N will be the total number of items. So 11 plus 1 is 12. And I'm picking the number of possible ways the 1 can be arranged. So that's 12 choose 1. Okay? And we did this down here. 12 choose 1 equals 12 factorial over 12 minus 1 factorial, which is 11 factorial, times 1 factorial, which is just 1. So 12 factorial over 11 factorial, well, all the 11 factorial cancels out. So, because you know factorial is 12 times 11 times 10 times 9, you know what I mean? So all that stuff is 12 up top. So you get 12. And the same thing for the other one. So I just plugged in all the points. So for this one to be, since a plus 2 is 10, n is 10, and r is 2. So I said 10 choose 2. And then for the next point, 5, 3, 8 choose 3. And then for the last point, 2 plus 4 is 6. So 6 choose 4. Right there. And you can see how I did the calculations the same way, just the the factorials, and then factorials cancel. So like here, for example, the only things left over would be 10 and 9 up top, because the 8 factorial cancels out. And then over to 2 factorial. So I just did algebra from there. And so for all those points, there's 5 points I had 12, the number of possible ways would be 12, 45, 56, 15, and 1. So I added all 5 of those numbers and got 129, and that's my answer.